Despite our strides in understanding the universe, some cosmic phenomena continue to perplex us, pushing the boundaries of our comprehension. Imagine this: a single particle existing simultaneously in two galaxies millions of light-years apart. Sounds impossible, right? Yet, quantum entanglement, a mind-bending phenomenon defying our classical understanding of reality, suggests this bizarre feat might be the norm in the microscopic realm. Today, we'll delve into 5 of the most mind-boggling cosmological theories that promise to challenge our perception of the universe, from the intricate ballet of quantum particles to the possibility of colliding branes and birthing universes in the multiverse. Welcome to Science with Lou. Join us on this cosmic expedition that promises to leave you contemplating the wonders of the cosmos. Exploring the baffling realm of simulation theory takes us to a crossroads where some see whimsical fascination while others scoff, deeming it sheer lunacy. This theory proposes that the cosmos and everything within it, including our own seemingly solid reality, might be little more than an elaborate computer simulation crafted by advanced civilizations beyond our comprehension. This notion, once relegated to the realm of fantastical sci-fi films like The Matrix, gained traction with a 2003 study by Oxford professor Nick Bostrom titled, "Are You Living in a Computer Simulation?" While the absurdity of this concept might be tempting to dismiss at first glance, it's worth noting that prominent figures in science have given it serious consideration. The core of this hypothesis lies in the possibility that a highly advanced civilization could design simulations so intricate and detailed that the simulated beings within us, for example, would perceive their artificial world as genuine, completely unaware of its fabricated nature. Proponents of this theory point to the remarkable advancements in virtual reality and computer simulations within our own society. Though creations like The Sims and Minecraft fall far short of this theoretical complexity, they do beg the question: could our own future advancements in artificial intelligence and virtual reality eventually lead to the creation of simulated beings capable of autonomous thought and action, blurring the lines between the real and the simulated even further? Defining the boundaries of this theory is no easy feat, as it can quickly veer into realms of unbridled speculation. Are we perhaps the digital offspring of an ancient master race that once walked our planet before transcending to a plane of existence beyond our grasp? Could we be mere players in a cosmic game orchestrated by an omnipotent entity, akin to how some envision God? This profound contemplation of reality itself is ultimately what draws us to the simulation theory. As theoretical physicist David Bohm observed, reality is what we take to be true. What we take to be true is what we believe. This intricate dance between belief, perception, and truth begs the fundamental question: what truly defines the reality we inhabit? The multiverse idea is one of the most interesting and controversial cosmologies. It suggests that there are many universes out there that are not visible to us. The idea that our universe, which consists of billions of galaxies, could be a little speck in a much larger multiverse is mind-boggling when one considers that the observable known universe spans approximately 94 billion light-years. Though it may appear to be a novel and avant-garde concept, its origins can be found in the works of 5th century Greek philosophers Leucippus and Democritus. After centuries of development, these concepts came to be known by the word multiverse, which was coined in 1895 by American psychologist and philosopher William James. This idea became ingrained in the general cosmological awareness throughout time, yet it is still very divisive. The multiverse idea is difficult to conceptualize. How do we imagine several enormous universes? Similar to a kid's ball pit, where each ball symbolizes a different world, is one popular visualization. Alternatively, picture a wide expanse filled with billions of individual bubbles, each of which represents a separate universe. It's important to remember that there is currently no empirical evidence in favor of the multiverse idea, despite these visuals. However, the theory becomes somewhat popular because of problems with current cosmological models. Consider the Big Bang, which is generally acknowledged to have occurred 13.8 billion years ago and given rise to our universe. So what was there before it? According to the multiverse theory, there were multiple Big Bangs that each started the growth that eventually resulted in distinct universes. Ours was just one of them. The idea that bubbles were created by the Big Bang and that they developed independently with their own rules and worlds is another. Proponents of the multiverse idea contend that this could explain why fundamental rules align so precisely for life to originate, as well as how physical constants are fine-tuned. There must be an endless number of combinations of atoms and particles if there are an infinite number of worlds. Some argue that a tiny percentage of them may be able to support life, which might account for the existence of life in our cosmos even while the bulk cannot. The Big Bang theory thrusts open the cosmic vault, exposing a fundamental enigma. What lurked before this monumental detonation that ignited our existence? What primordial tapestry predated life's first flicker, and what became of its threads? Here, we encounter the ekpyrotic theory, also known with less lyrical grace as the Big Splat. This theory envisions our universe birthed from the cataclysmic crash of two higher-dimensional universes, termed branes, woven into the very fabric of a reality far beyond our mortal grasp. Before tackling the Big Splat's explosive elegance, let's cast a curious glance at the brane theory, intricately entwined with the multiverse hypothesis. Brane theory, nestled within the grand tapestry of string theory, proposes our existence nestled within higher dimensional membranes, mere ripples in a cosmic pond brimming with unseen realities. While we navigate a mere 4 dimensions, 3 spatial and 1 temporal string theory suggests up to 10, each segment of our membrane experiencing a unique dance of dimensions. Our observable universe might be but a single sheet in a vast stack, separated by cosmic abysses, each layer pulsating with its own universe, governed by unique laws and playing out cosmic ballets unseen. Now, we descend into the heart of the Big Splat, the electrifying proposition that a universe erupts from the collision of these cosmic membranes, their kinetic energy transmuted into a primordial fireball, the Big Bang, igniting the spark of life anew. Imagine 2 titanic cosmic tapestries, immense curtains of energy, colliding in a cataclysmic event that would shatter any known scale. This celestial car crash would unleash energies beyond our wildest nightmares, birthing our universe and sending it careening outwards in an endless expansion. This intense inferno would fling the membranes apart, setting them on a trajectory of ever-increasing separation. Yet, within these theories lies a tantalizing suggestion. The universe and the life it cradles might be locked in a cosmic waltz. This cyclical perspective proposes that the membranes, after eons of expansion, eventually begin to decelerate, their cosmic dance reversing, drawing them inexorably back towards each other. Upon their inevitable reunion, another Big Bang would erupt, spewing forth 2 newborn universes, undoubtedly bearing forms unimaginable to our mortal minds. This perpetual cycle, a cosmic Ouroboros, would perpetuate the endless birth and rebirth of universes, each iteration a fresh canvas awaiting its own symphony of existence. Delving into the cosmic playground of white holes, where the usual rules get flipped on their head, makes even black holes seem straightforward. Picture this. A colossal star, its fuel spent, succumbs to gravity's crushing embrace, folding in on itself until it becomes a cosmic vault, hoarding everything, even light itself. This cosmic lockbox is the event horizon, the point of no return for anything that wanders too close. Black holes, some say, might even be cosmic drain pipes, funneling matter and energy into hidden realms, perhaps even forming a galactic superhighway if you connect the dots between universes. Now, if these cosmic vacuum cleaners have an exit, wouldn't they need a spigot on the other side? That's where white holes come in, the theoretical counterparts of their dark brethren, spewing forth an energetic fountain of matter and energy instead of sucking it in. While no one's actually found one yet, these cosmic geysers have captured the imaginations of scientists and cosmic dreamers alike. Einstein's gravity theory, a cornerstone of our understanding of the universe, provides the stage for this cosmic dance. He proposed that gravity isn't a force, but rather a curvature in the fabric of space-time itself, caused by the presence of mass or energy. Imagine a bowling ball placed on a trampoline. The ball creates a dent, and any marble rolling nearby will naturally curve towards it, just like how planets orbit the sun. This explains why black holes, with their immense density, warp space-time so dramatically, creating event horizons beyond which even light can't escape. So, could white holes be the cosmic counterparts to these space-time dents, spewing matter and energy instead of simply bending their surroundings? The idea tantalizes scientists, hinting at a universe where energy flows not just inwards, but also outwards. While the existence of white holes remains unproven, their hypothetical role in this cosmic ballet adds another layer of wonder to the already breathtaking tapestry of the universe. Whether whispers or shouts, the possibility of white holes keeps our minds ablaze with questions. They serve as reminders that the universe, our grand cosmic playground, is still brimming with secrets waiting to be unraveled. So let the speculation dance, let the equations pirouette, and let's keep our eyes peeled for the day we glimpse the first cosmic geyser in action. And as we continue exploring this cosmic playground, perhaps we'll find new ways to understand and appreciate the unseen forces, like gravity, that shape our universe and everything within it. This edition briefly explains gravity as a curvature of space-time caused by mass, using the bowling ball and trampoline analogy to make it more relatable. It then connects this concept to the possibility of white holes as counterparts to black holes, highlighting the potential flow of energy outwards. The focus remains on the mystery and wonder of these celestial objects while acknowledging the ongoing scientific exploration. Every so often, a cosmic whisper tickles the ears of those scanning the heavens for the faint echoes of extraterrestrial intelligence. While these tantalizing murmurs are often followed by hushed cautions against unwarranted excitement, they keep the embers of our interstellar aspirations glowing. Since the late 1950s, humanity has cast its radio telescope ears towards the cosmos, yet a truly definitive signal remains elusive. However, within this grand celestial search, glimmers of intrigue have pierced the cosmic silence. The most famous whisper dates back to 1977, when astronomer Jerry Amon stumbled upon a peculiar anomaly at Ohio State University's Big Ear radio telescope. This intense burst of radio waves, dubbed the WOW signal, lasted a mere 72 seconds, originating from the depths of the Sagittarius star system. Though its source remains a celestial enigma, it sent a jolt of renewed energy through the SETI program, reminding us that the vast, unknown beckons. But advances in technology have sharpened our cosmic listening tools, offering new and captivating leads. Initiatives like the Breakthrough Listen project have detected promising signals from Proxima Centauri, our closest stellar neighbor, and YZ Ceti, a diminutive red star harboring a potentially habitable exoplanet. While these discoveries often attract the skeptical murmurs of pulsars, rapidly spinning neutron stars that naturally emit strong radio waves, they continue to ignite our imaginations. For beyond the realm of natural phenomena, whispers linger about the possibility of pulsars manipulated by advanced civilizations. This fringe theory suggests harnessing these cosmic beacons for interstellar communication, or even utilizing their powerful pulses as a means of interstellar propulsion, propelling spacecraft through the cosmos at speeds that would make our current rockets blush. A 2014 paper, published in the esteemed journal New Astronomy, even proposed that information could be encoded within a pulsar's radio waves, perhaps transmitted by an orbiting satellite or intercepted and interpreted through a specially constructed structure. This audacious notion, while venturing into the fringes of plausibility, underscores the boundless nature of scientific inquiry and reminds us that what was once deemed fantastical may one day warrant serious consideration. As we navigate these cosmic theories and speculative possibilities, remember, the pursuit of understanding the universe isn't just about finding answers, it's about embracing the questions that lead us to new realms of thought. Join us again as we continue to unravel the mysteries of existence, sparking curiosity and contemplation on the limitless wonders of the cosmos. Before that, make sure to leave a like on this video, subscribe to the channel, and ring the notification bell for more videos like this. Until next time, keep looking up and keep wondering. See you